What's up, everyone? Are you looking to add search functionality to your Payload CMS project, but you're not quite sure where to start? This video will go over each step you need to do to enable that search functionality in Payload CMS, as well as how to render it on a Next.js front end. We'll start with the backend setup while reviewing each of the options available to you. We'll then wrap up with a fully functional search route that allows users to search through the collections you've enabled. If you want the code that I use for this video, there's a link to the repo in the description. Now, let's dive in. One thing you should know before we get started about the Payload CMS search plugin is that it doesn't work like third-party search providers like Algolia out of the box. While you could use intercepting routes to set up a modal for your search route, that will take some configuring and will be beyond the scope of this video. Instead, we'll simply use a search route. Let's get started by installing the search plugin using npm add at Payload CMS plugin search. And once that's done, you always want to make sure you can go to your package.json and ensure that everything is on the same version. So it looks like we have all on the same version, but I'll get rid of this pin just in case. Now here in our payload config file, we can import our search plugin and just pass in an empty object for now. Now you'll want to make sure that this imported automatically. I know it did for me, so I'll continue on. Now that this is in your configuration, let's discuss what options are available to you with this plugin. Collections is the only option you need to get started, so we'll include our posts and our pages. This is an array of collection slugs where you would like search to be enabled. When you enable search on collections, they will receive a before change and after delete hook that keep your search records up to date as you add, edit, or delete content. The search plugin automatically enables localization to the title field of the search collection if you have localization enabled. If you don't want this behavior, you can set localize to false. I don't have localization enabled yet, so it doesn't matter. However, I will set this to false for now. A priority field is automatically added to the search collection when it's initialized. You can use this field as a way to sort your search results using the sort parameter in your local API, REST API, or GraphQL queries. Use cases for this might include having your homepage show up first in relevant search results, or if you want to ensure your pages show up before all of your posts. First, we can add our default priorities option, and it's going to take an object. Then we can pass in a collection slug. So we'll set posts to just a number, which will be 20. So anytime a new post is created, it will be automatically assigned the default priority value of 20. But we could also include our pages, which takes a function, and this function takes the doc argument. And so now, if I have my doc slug equals home, I can set a default value of 1, and then for everything else, it can be 10. This simply sets a default fallback for you when a search entry is created from a collection. You are able to change it if you want to in the search collection. When you initialize the search plugin, a search collection is created. This follows a default pattern, but you're able to override anything in the plugin using anything from the payload collection config. So we'll add below our default priorities, we can add our search overrides. And if we wanted to, we could update our slug to be search results instead of just search. We can include labels, which will need to include both the singular and the plural, which will be search result and search results. We even have access to our admin options, and so we'll group this in a search group. If you want to add or edit fields, you can do that using the fields option, which expects a function with the object of default fields. And we need to pass this into our array with the spread operator, so we receive all the default fields. And then we're going to add two fields. One is going to be an excerpt field, and our excerpt field is going to be a type of text area. And the other field is going to be slug with the type of text included as well. Later on, we'll be able to use these two fields also to help us search through our search collection. If you want to modify anything while the search record is being created or updated, you'll want to use the beforeSync function. There are much more advanced use cases for this, like ensuring your post categories get updated as well. We'll do more with the beforeSync function later on when we render this on our front end, but for now we can just add a default value for our excerpt and slug fields in the search document. So we'll add below our fields our beforeSync, which expects a function, and we can pass in our original doc and our search doc. We are also able to take rec and our base payload object, but for now we can just pass in our search doc defaults using the spread operator. But then we need to tell the search collection where to get the excerpt field we created. Otherwise, it'll return a string that just says fallback excerpt. This is something you'll need to create in your search-enabled collection if you want to use it. So I'm going to add our excerpt, which will take our original doc. And just for an example, we can just pass in our excerpt, which does not exist on this type, but we'll do a fallback excerpt. And then for our slug, we can get our original doc slug or a fallback slug. As I mentioned before, you also get your rec object and base payload object, and you can use these for more advanced querying and other logic. If you have drafts enabled and syncDrafts is set to true, you'll see drafts appear in your search results. By default, though, syncDrafts is false, so you would need to opt in to that behavior. We'll leave syncDrafts set to false because I don't want my drafts to be seen in search results. Similarly, we have default drafts, which will delete search results when the original document is set to draft. This is true by default, so we'll leave this as true in our configuration, but if you want drafts to be included in your search results, you'll want to set deleteDrafts to false. The last option available to us is reindexBatchSize. This option takes a number that defaults to 50 if it's not set. This option will determine how many search documents to fetch for reindexing at a time in each batch. This is an optional property, so if you don't have a specific need to change this number, don't feel like you have to. Now that we've configured our search plugin, we can see what this looks like by running pnpm dev and going to our admin panel. We see right away that our search collection is in the search group and labeled search results, just like we defined. If we click on the search results, we see that nothing has been created yet. Since we created documents before adding the search plugin, we'll need to reindex our site to show the search results. You can do this by clicking on the reindex button and clicking on either a single collection or all collections. In my example, you'll notice that blog posts shows up in a user-friendly way, but the pages collection just looks like the collection slug. I'm going to update this by adding a labels option to my page config under its slug. So I can go to our pages collection config, and then underneath the slug up here, I can add my labels option, which again will need a singular and a plural value. And now when I save this, we'll see that our pages option gets updated here. Now I can reindex all collections and hit confirm. Clicking into any one of our documents here, we can see that we have an additional excerpt field that took the fallback excerpt I set. Since this is set in the beforeSync function, this got updated even though the document was already created. I bring this up because if I go to my home page, we can see that the priority is set to 0 rather than 1. Luckily, I can just update this manually and hit save. If your documents aren't sorting like you want to by priority, make sure that the priority value is what you expect it to be. From here, you can edit the doc by clicking on the edit button in the doc field here. And you can also navigate to the document by clicking on the doc URL below it, and this will open in a new tab. And that's it for the back end. So now let's get this rendered on the front end. Before we do that though, check to make sure you're subscribed to my channel so you never miss when I release new content about Payload CMS, Next.js, and other modern web dev technology. Tired of trying to keep up with all the news and updates across the technologies and companies you use? Sign up for my newsletter to get a bi-weekly overview of all the dev news from across the internet. The link to that is in the description. Thank you for your support. Now, let's get back to it. There's no out-of-the-box search component provided by Payload CMS, which means you'll need to do it yourself. This gives you a ton of flexibility on how you want to do it, but I'll walk through how I'd implement this so you have an idea of what you can do. We'll first want a way to minimize the impact on our database from our search component. If we were to set up a way for people to just type and hit enter, we wouldn't need to worry too much about this, as the query would only go through once. However, I want to enable the search bar to populate results in real time, which would result in many hits to our database very quickly on each change. In order to minimize this, we can create our own hook called useDebounce. Debouncing refers to a technique used to control how often a function runs. Since we plan on returning data as a user types, that would mean that after each keystroke the user provides, the search function would run. Our debounce function will wait until we stop typing for a short delay before returning anything. So to start, we'll go to our utilities directory, and we're going to add a new file called useDebounce, and this will be a TypeScript file. To start, we need to import our useState and our useEffect from React. We'll export a function called useDebounce, and we'll make this function generic. That means it'll work with any type of value. So we can pass in our value with, again, a generic value and a delay of a default of 300. And the function will resolve to a generic value as well. We'll create a useState hook, which will get and set our debounced value, and our default value will just be value. We'll want to run the effect every time the value or delay changes, so we want to use the useEffect hook. For the dependencies, we can pass in our value and our delay. So now let's get to work on the function itself. We'll create a new constant called handler, which is going to set a timer based on an interval that we set. So we can pass in our delay here as the second option. So in the function itself, though, we'll set our debounced value to value after the timer expires. Now, if the value changes again before the previous timer expires, we'll cancel the previous timer, which will then start a new one, ensuring that only the latest value is used after the delay. And we can do that by returning an anonymous function, and we can use clear timeout on our handler. Then we can return our debounced value. Next, we'll need to set up our search component that will take our debounced value and send it to the server to be used in our search query. I'll first create a new directory in our components folder called search. So components, new directory, search. And in this search directory, I'll create a new file called component.tsx. And as I mentioned, this will need to be a client component. So I'll use the useClient directive here at the top. And then I'll import React, useState, and useEffect from React. And then we can bring in our useDebounce hook that we created. And then we can import useRouter from Next Navigation. And then we need to export a constant called search. And search is going to have the type of React FC. And then we can open up our constant here. We'll start with a useState hook, which is going to set and get our value with a default value of an empty string. And then we can initialize our router and store it in a router constant. And then we can do the same thing with our debounced value by setting it equal to the useDebounce hook and pass in our value. Now we need this to run on each render. So again, I'll use a useEffect hook, and we'll use our router to push our debounced value, if it exists, to our search route, which we haven't defined yet. If there is a debounced value, we'll append our route with a parameter called q and set it equal to the debounced value. Otherwise, we'll return an empty string. And here's what that's going to look like. So we have our search route, and then we'll check if debounced value exists. If it does, we will use a question mark for our query parameters, and then pass in our debounced value. And if it does not exist, we'll pass in an empty string. And for our dependencies, we need our debounced value and our router. Now we can return our component. We're going to include a form that has an onSubmit attribute, which is going to take an event as an argument, and then prevent default as its only action. And then we're going to have a label, which will say search, and it'll be HTML for search and we'll give this a class name to hide it from everything and everyone except for screen readers. And then we'll need an input, which will have an ID of search. It'll have an onChange attribute to set our value to our event target value. We'll give it a placeholder that just says search, and we'll style this up a little bit to have a border emerald 950, text emerald 950, rounded medium, padding left and right of 1 rem, and then padding top and bottom of half a rem. And then under this, we're going to have a hidden button just for accessibility, which will be type submit. It will have a class name also of screen readers only, and we can just include submit as our button text. And that's it for the client component. So let's revisit beforeSync. Before we set up our search route and render our search field, we should go back to our beforeSync option so we can do things a little bit more streamlined and a bit more powerful. I'd like to be able to search on my post's rich text. Out of the box, though, we're not going to be able to easily search the contents of a rich text field without first converting it. So what we're going to do with our beforeSync option is convert our lexical data to plain text to then be used in our search function. I also want to be able to search all the text in each of my pages or posts. That means we'll need a way to convert blocks to plain text as well. To do this, we're going to add a new file to our search folder, and we'll call it beforeSync.ts. At the top of our file, we need to import beforeSync as well as doc2sync from our plugin search types. And we also need our serialized editor state from payload lexical. And then we're going to import a function called convert lexical to plain text from our rich text lexical package plain text. We can then export a new constant called beforeSync with search and assign it the type beforeSync and set it equal to an async function. And just like in our configuration, we can pass in original doc and search doc, and of course rec and payload are there for you as well. And we're going to destructure our search doc by pulling out our document relation to and get our collection from that search doc. And then we're going to get our title, content, and slug from the original doc. Let's start with converting our page blocks to plain text. We can start with a constant called page text, which will expect an array of strings, and we'll initialize it with an empty array. And then we'll want to check if our collection is equal to pages. Since my pages and posts are structured a bit differently, the name content is used in both collections for different things. So we want to make sure we avoid confusion there. To avoid further confusion, we're going to destructure our original doc cast as a page from our payload types. And we're going to pull out our content and rename it to be page blocks, which is what this content is. We can then use the forEach method to go through each of our page blocks and pull out a block, and then we can do something to it. We'll need to do this for each block type that we want to convert. This may make more sense as a switch statement as it grows in complexity, but for now, we'll just make use with a basic if-else statement. Starting with our content with media block, we'll check that content exists. So if block type is equal to content with media, and there is content in that block. If it does, we can push our convert lexical to plain text with our data being block content. And so what this is doing is it's checking if our block type is content with media and that block has content. If it does, it will push this value to our page text array up at the top there. We'll do this again with our form block. So I can get my block type, and set this equal to form block. And since all of my blocks are going to be slightly different, we need to get different pieces of information. So we're going to destructure our block, and we're going to get enable companion text, and our companion text, which is what the rich text field is called for our form block. If our companion text is enabled and that companion text exists, we can do the same thing by pushing the plain text version of this to our page text array. So we'll convert lexical to plain text and pass in our data, which will be companion text. The last example I'll cover is from my nested blocks example in a previous video. We'll first check for the section type. So we'll say if block type is equal to section. And if it is, we want to check if that block has a row. And if it does, that row is an array. So we'll need to go through each row to pull out every column and then get each column, pull out our content, and then go through our content for each content block, and then check if our content block type equals text, which would be the only block type with rich text in it because the other is video or image. And we can check then if our content text exists. If it does, we will push the plain text value of our data, which is our content.text, to our page text constant. Now let's process our lexical content. We'll store our content in a constant called data. So we'll take our constant data and have it be assigned our serialized editor state and set that equal to content. And we'll need a way to instruct our convert lexical to plain text function how we want our blocks converted. So we'll create a new constant called converters, which will be assigned the plain text converters type. And in this type, we'll use our default node types, as well as our serialized block nodes with just our content with media type included. And I'm only going to cover one of my block types, but the process would remain the same for all other block types as well. Inside this, we can pass in our blocks option, which will take our content with media. And within this, we'll have our node. And we can simply return our plain text converting function with our node field's content as data. So return convert lexical to plain text, and then pass in data from our node field's content. And this can't be a null value, so I need to use the non-null assertion right there. We can then use the convert lexical to plain text function on our data and store it in a constant called plain text. So we'll use constant plain text, set it equal to convert lexical to plain text, and we're going to pass in our converters and our data. And you may get a type error here. I am. But this provides a valid output, so you can just tell TypeScript to expect an error here. After that, we can put it all together and store it in a constant called modified doc. So constant modified doc, and this will be type of doc to sync, and set it equal to an object. We'll pass in our search doc defaults, just like we did in the general configuration. Then we'll pass in our title and our slug. And for our excerpt, we're going to check our collection. And if it's equal to posts, we will provide our plain text. Otherwise, if the collection is equal to pages, we can join our page text array with a white space. Otherwise, it can just be an empty string. Finally, we need to return our modified doc. Now, with that done, we can replace our beforeSync function with this function that we just created, beforeSync with search. And of course, you'll need to make sure that this got automatically imported like it did for me. As I mentioned earlier, we won't be setting this up as a modal like one would expect from Algolia search, though you should be able to set this up fairly simply using an intercepting route. That means we'll need to include a route to direct users to if they want to use the search feature. Let's create a new segment called search in our front end directory here. So new directory, search, and within search, we'll add a new file called page.tsx. And in this page, we'll need to import our config promise. And this is going to come from our payload config. We'll also need get payload from payload. We'll need React from React. And we can import our search component from our components search component. And I plan on rendering our search results as links to the documents. So I'll also import link from next link. And for good measure, we're going to import our type of metadata from next so we can, of course, include some metadata in our search route. Let's start with a type called args, which is going to take our search params, which of course is a promise, and we're going to get our search query Q as a string. We'll then export our default async function called page with our search params, which we'll rename to search params promise, and make sure our args type is assigned to it. Then we can open up our function. Let's store our query Q in a constant that awaits our search params promise, and then initialize payload. We can then find all of our posts by awaiting payload find, and look in our collection for search results, and we'll keep depth at 1, and we'll limit our search results to 6, and we're going to select just a few things. First is going to be title, excerpt, slug, and then our related doc. I'll set pagination to false to reduce overhead, since we don't need total docs. And then we can set up our query and check that it exists. If it does, we'll pass in a where query, which will be an array of OR statements. And in the OR statements, we'll first check title is like query. And then we can just duplicate this twice and change title to excerpt, and then the other title to slug. Otherwise, we can just pass in an empty object. Now we can return our page content. So we'll return starting with a div, which will be a container div, and we'll add a class name of padding y of 24, and then another div, which will have a class name of margin bottom of 16, then another div with a class name of text center, and this will contain our h1, which will have a class name of margin bottom 8, large margin bottom 16, and then text emerald 950, and we'll have the value of search. We'll then have another div, this one with the class name of margin left and right of auto, and this will hold our search component. Now, still within the main container div, we're going to set up another div that is going to be class name of flex gap 4 justify center. In here we can check that our total docs is greater than 0, and if that's the case, we can map through our docs by pulling out our doc and passing in a callback function. And to make things cleaner, we will create a constant called relation2, which will store our doc relation2. And then we'll create another constant called slug, which will check first that our doc slug is equal to home. If it is, we'll just return a /. Otherwise, we'll check that our relation2 is equal to posts. And if that's true, then we can do /posts and then our doc slug. Otherwise, we can just pass in our doc slug. Now we can return our link component here, which will take our doc title as the link name, and we'll have the href be slug, which can't be null, so we'll use a non-null assertion operator there. And then we'll pass in a couple of class names, the first being padding top and bottom of 2, padding left and right of 1 rem, text emerald 950, border emerald 950, rounded medium, and then a couple of hover styles, the first one being text emerald 50 and another one being hover bg emerald 950. If total docs is less than or equal to 0, we can just pass in a div that says no results found. One last thing in our link here is that we need to pass in a key, which can just be our doc ID. Lastly, below all of this, we'll export our function called generate metadata, which will have the type of metadata assigned to it, and will return just our title in an object, which will just say NLV codes example search. Before we test our search, we want to make sure that we have everything populated correctly. So we're going to go back to our search results, and we're going to reindex all our collections and hit confirm. So when this loads up, we can look in our blog1 test, and we see a bunch of text show up, both in our content with media block and from our rich text. So now if we refresh our search route, I can search by our slug, I can also, even though Tailwind is not included in any of these slugs or titles, I can still search for Tailwind. And of course, title, but that's a given at this point. So yes, the documents update in real time, but if we look in my console, we can see that I'm not getting a different search query for every keystroke. And that is the effect of our use debounce hook. And that's it for the search plugin. You can expand on the functionality of this plugin even more using the beforeSync function or adding more fields on which to search. You can also change how you render this using more advanced Next.js routing features or different styles. Since this is not a built-in component, you're able to do whatever you want to create this functionality. Hopefully this video has given you a good idea of what you're able to accomplish though. If you found this video helpful, please like it and share it with others who might also find it useful. Check to make sure you're subscribed to my channel and receiving notifications so you never miss when I release more content about Payload CMS, Next.js, Tailwind CSS, and more. Also, consider subscribing to my newsletter to stay up to date with modern web dev news from across multiple platforms. There's a link to that in the description. If you have suggestions or questions, please leave those in the comments. I'd love to hear from you. Until then, I'll see you on the next one.